So there's a spider that's 100 feet across, and we're assuming it looks like a sphere. Okay, it's a big assumption because a spider obviously isn't like a perfect baseball, but we're going to assume it's a sphere. That way we can use these equations. Um, so it's 100 feet across. That means it has 50 feet for a radius. And so the question is, can this spider absorb enough oxygen through its exoskeleton to sustain its volume? Because it's a huge spider. And so we're going to assume a spider needs 26 milliliters of oxygen per cubic centimeter of the volume of the spider per second. And then we're also going to assume that it absorbs it at 26.4 milliliters per square inch of surface area per second. So, the surface area grows at a slower rate than its volume because volume is cubic and surface area is squared, right? So that's the big point of this, is that these spiders in these old horror movies couldn't exist. Okay, so let's find out the volume of the spider. The volume of the sphere is 4/3 pi r cubed. So 4/3 pi, and our radius is 50 in feet. So we want to use ft cubed here for our units. We want to remind ourselves of that. So I've got 4/3, there it is as a decimal, times pi times r squared. So 523,600 cubed feet. But we need to convert this to cubic centimeters, okay, so that we can calculate its milliliters of oxygen it needs per second. So this is cube feet. So we can do a quick Google search. We can say 1 foot equals how many centimeters? So 1 foot is 30.48 centimeters. So I want to multiply this by 30.48 centimeters in the numerator and 1 foot in the denominator to try to make the feet cancel out. But this is feet cubed and this is feet to the first, right? Linear feet. So they can't cancel out. But what I can do is I can raise I can raise this to the third power, because look, something divided by itself is 1, and 1 to the third power is still 1. So I can raise them both to the 1/3 power without breaking any math rules. So 523,600 cubic feet. And then that's 30.48 cubed. 28,316.85 in the numerator, and then that's cube feet in the denominator. Okay, so now the cube feet can cancel, so we just got to multiply those two numbers. This is a huge amount of cube centimeters, right? So that's that many cube centimeters. Okay, and then up here it says for every 1 cubic centimeter, we need 26 milliliters of oxygen. So if you need 2 cubic centimeters per cubic centimeter, let me think about that. Okay, so if we take 26 milliliters, so we want to multiply to make the cubic centimeters. This is 26 milliliters per 1 cubic centimeter, it tells us. That's how many milliliters of oxygen it needs per second. So if we multiply those, it's a huge amount of milliliters. So we need this many milliliters for 1 second. Okay, because this is how many milliliters per cubic centimeter per second. Right, so we make the centimeters cancel out, leaves with just meters per second like we wanted. So that's how much it needs. That much oxygen per second. Let's find out how much it can absorb, and that involves the surface area. Okay, so let's do what we did before, except this time we're using a formula for surface area. So the surface area of this thing, I'll use A for surface area, is 4 times pi, I'll use my approximation, times r squared. So this is in feet. I want to remember our units there at the end. 4 times 3.14 times 50 times 50. So that's 31,416 feet squared. and this time they want us to calculate per square inch. It absorbs 26.4 milliliters per square inch. So we can convert this to square inches. If we multiply this by, there's 12 inches in a foot, but that's not square measurement, so you want to square the top and the bottom. So you've got 31,416 square feet times 144 square inches over 1 square foot. So the square feet cancel out. So multiplied by 144, so that's 4,523,904 square inches of surface area that this thing has. And it can absorb 26.4 milliliters per square inch per second. So we'll do the same thing. We got to multiply by 26.4 milliliters per square inch, and that's per second. So the square inches will cancel like we wanted. So we've got this times 26.4. So it can absorb this many milliliters per second. So it can absorb around 119 million milliliters per second, but it needs 385 billion milliliters per second because of its volume. So this spider could not exist. Its needs outweigh the absorption capacity of its exoskeleton by a lot.